Physics chapter 31, theory video 1, astronomy and cosmology is what we are going to discuss about. Now you know that the universe is a massive place, and the universe is made up of massive celestial bodies known as stars, galaxies, and nebulas, many things. So this a galaxy is a massive place. It actually has as many as 10 to the power 11 stars, and there could be as many as 10 to the power 11 galaxies in the universe. So there are that many stars and that many galaxies. So that you can understand how massive the universe is. So this light from these galaxies actually travel in the finite speed, that is 310 to the power 8 meters per second in a vacuum. Because the universe is mostly a vacuum, they will travel in that speed. If as I have explained to you before, if a star or a galaxy is a billion light years away, so that means it would take billions of years to reach us. Now we are looking at, I have explained this to you earlier. So if you are looking at the night sky, we are looking at the past. The closest galaxy to us is the Andromeda galaxy. So it takes about 2.3 million years to reach us. So if we are looking at this galaxy through a telescope, we are looking at its image 2.3 million years ago. If someone from Andromeda galaxy looked at us, so they would see how the Earth looked like 2.3 million years ago. So now in this chapter, what we are going to look at is we look at how galaxies move about and how it expands. Now we know that the universe began or created 14 billion years ago. So don't be misguided by the use of this word created. So there is no creator, it is just created in the sense it came into existence the way we know it 14 billion years ago. So there was a phenomenon known as Big Bang, but that is all we know. So our knowledge is limited to that. We do not know whether there is anything beyond the Big Bang. That doesn't really mean, just because we do not know that doesn't really mean that it is a higher power. Obviously, the nature itself is a higher power. So people might call it different words, but we are talking about the Big Bang as the beginning of the existence of our universe. When we look at the sky, all the stars that we see in the night sky, they are all from the Milky Way galaxy. That is our own galaxy. So in this figure, if you look at the book, you would see this figure. So these are the stars in the constellation of Gemini. They are not the same. They have different brightnesses, they have different colors. So that is because of these different colors and brightnesses could be a reason, could be because they are at varying distances from us, and they do not emit the same power. So with these things, by taking these things into consideration, we can actually get an understanding as to where it is, that is how far away they are, simply by looking at their brightness. So when it comes to astronomy, luminosity of a star is defined as the total radiant energy emitted per unit time. Luminosity of a star is the total radiant energy emitted per unit time. So that is in turn similar to the total power emitted by a star. So if you take in SI units, luminosity capital L is obviously measured in watts or joules per seconds, because it is power emitted by this particular star. The closest sun to the earth, my apologies, the closest star to us, star to the earth, is the sun, because the sun by itself is a star. So because it is really close to us, we can actually determine its luminosity to a very high degree of accuracy. We say that it's the sun's solar luminosity. It is written as L O with a dot in the middle. We say that it is about 3.83 into 10 to the power 26 watts. So you can understand that it has a huge amount of power that we can't even comprehend. We can determine the solar luminosity from the intensity of solar radiation that reaches the earth. So that is something that we will be learning at a later stage, and you will be able to do the calculations based on that. Then there is another term that we have to take into consideration, that is the standard candle. So this standard candle is any astronomical object of known luminosity. We can determine the distance of a standard candle by measuring the intensity of the electromagnetic radiation that arrive at the earth. So we use these standard candles to determine the distances of far away galaxies. We can actually get an understanding how much what is the distance that these things are placed at by looking at the light that reaches us. And there are two well-known standard candles, which these are specific objects that we kind of make consider to be a kind of a model. The most well-known standard candles are Cepheid variable stars and type 1a supernova. These are actually most prominent standard candles. So these Cepheid variable stars are kind of a particular type of stars that varied its brightness periodically. So this period of the variation was related to the average luminosity of the star. So by measuring that particular period, they were able to determine the luminosity of the star. So if you know the luminosity of the star, you can measure the distance of the star. So that if they can find a Cepheid variable star, that means a star that changes its brightness periodically, then if they can find that in a galaxy, then they are able to find the distance of that galaxy from the earth. Then type 1a supernovae, here because it is supernova is singular. So these type 1a supernovae stars implode at the end of their lives. So implode is to kind of crash onto itself. they scatter matter and energy out into the space when they do this. So this particular event will produce so much bright light that is brighter than the galaxy itself. So at the when this implosion takes place, the luminosity of the star would be the same. So from that also we can figure out the star's distance from the Earth, and if you know the star's distance, then you can figure out the distance from the Earth. Write down a note on this. Standard candles. Underneath that, right? Luminosity of a star is the total radiant energy emitted per unit time. Total radiant energy emitted per unit time. Which is equal to the total power emitted by a star. Therefore, luminosity L is measured with watts or joules per second. The luminosity of the sun, within brackets solar luminosity, L, then that dot and O, is about 3.83 into 10 to the power 26 watts. Leave a line and write. If the luminosity is known, we can calculate the distance at which the star is located. To help with this, we use an object known as standard candle. This is an astronomical object of known luminosity. By measuring the intensity of the electromagnetic radiation that arrives the Earth, we can find the distance of standard candle. There are two well-known standard candles, Cepheid variable stars and type 1a supernova. Write Cepheid variable stars, put a dash and write down. In these stars, the brightness varies periodically. When the period is measured, luminosity can be calculated, thereby the distance can be calculated. Then write type 1a supernovae, put a dash and write. These implode rapidly giving out more light this light during the time of implosion is always the same, and as a result, the star's distance can be calculated. I hope you understood. If you didn't, please ask questions.